Okay, so let us discuss questions like how to apply little small method, or like something which will help you to solve the question in little easy way. See, all questions you cannot say that we can solve in 1 minute. There are some question you can solve in 30 seconds also. There are some question which will take more than 1.5 and 2 minutes also, right? So overall, on an average, each questions would be given 1 minute like that, but not necessarily. Some questions can get beyond than that, some question can be less than that. Less than that will be less number of questions like that. So we have this current sensitivity and voltage sensitivity concept, moving coil galvanometer. Here they have given you, in this you have been given current sensitivity of moving coil galvanometer. Current sensitivity means nothing but theta upon I. This is fan by C. Current sensitivity is actually, this is the definition of current sensitivity. Voltage sensitivity, and so on the sensitivity you get theta upon V, that is band divided by RC, equation number 2. Now both have been given. Current sensitivity is given 5 division per milliampere, so that milliampere you need to change it, plus 3 will become, because 5 divided by 10 to the power minus 3 numerator becomes here division per ampere, plus 3. This is because here 5 division per milliampere, milliampere means 10 to the power minus 3 numerator plus 3, right? Here 20 division per volt, right? And if you divide this side, this 2, if you divide this band and band will get cancelled, the C and C get cancelled. So here 1 by 1 divided by 1 by R, finally you left out only with R only, resistance. So here we just take numerically part, then you will get 5 into 10 to the power 3 divided by 20, that is your resistance, right? And here actually you can write as 5 into like 1000 divided by 20. So if you do this 50 times, the resistance will be 250 ohm. 55 is at 250, right? Next, let us see this. A galvanometer of 50 ohm resistance has 25 divisions. A current of 4 into 10 to the power minus 4 ampere gives a deflection of 1 division. It means here 4 into 10 to the power minus 4 ampere gives deflection for 1 division. And it has got total 25 divisions, right? So total current actually you can find out here. Current is equal to 1 division giving you 4 into 10 to the power minus 4 ampere. Okay, total 25 divisions means we have total current is 25 into 4 into 10 to the power minus 4. That is 25 for the 100, 100 into 10 to the power minus 4 gives you 10 to the power minus 2 ampere total current. So this is your initially current, and resistance of galvanometer is given is 50 ohm is given in the first thing. Now he is saying that to convert this galvanometer into voltmeter having a range. So actually you have to convert into voltmeter. So convert into voltmeter means you have the resistance formula R is equal to, it should be connected in series. Galvanometer resistance is given N, you have to find out, and N actually is new range by old range, right? So actually here you have been given current, you have not been given the voltage. So actually voltage, that is old range of voltage, you find out voltage, old range is current into resistance. Current is 10 to the power minus 2, resistance is 50, and the voltage of new range voltage is given as for you is 25 volt. So in value get as new range by old range. New range is what? 25 volt. Old range is 50 into 10 to the power minus 2. So here you get 25 2s, and here if you take this you get 100 by 2. So n value is 50. Okay, n value is 50, you get So n value you get 50 in this, then what you can do is n value is 50, then you can actually find out here galvanometer resistance 50 and this is 50 minus 1, you get 49. Then you multiply here 2450, that is in series connection. Okay, here given this is 2023 question, yours 2023 question, this one is very simple model. So like here you have to find out the net magnetic field. So actually total magnetic field, if you will like to have no confusion, you will write this is the first part, this is your second part and this is the third part. Due to these three parts you will have total magnetic field. So B1 plus B2 plus B3. So the first part actually it is semi-infinite wire. For semi-infinite wire you write mu naught I by 4 pi into d. D is the distance from this wire to the point where you have to find out magnetic field. This is distance r, so 4 pi r. Now here you see current is actually, if you look at it, is clockwise direction. For clockwise direction, if you imagine it is clockwise direction, for clockwise direction the magnetic field will be into the plane. Second one is semicircle, and due to semicircle the magnetic field will be mu naught I by 4r, and this is actually anti-clockwise. Anti-clockwise, if you look at carefully, it is anti-clockwise. Anti-clockwise is out of the page or out of the plane. Plus, now if you see, this is again semi-infinite. Semi-infinite, one end is closed, one end is infinite. Then you again write mu naught I by 4 pi r. And this is also into the plane. Now into the plane and into the plane, here there is nothing like something should be positive and negative, no positive negative. Similar type of magnetic field will be added, that's it. So 2 times if you do it, so actually you will write 2 into mu naught I by 4 pi r, right. So you get here this is actually into the plane. And next one is mu naught I by 4r, that is out of the plane. Okay, so if you cancel this 2 times, it will get cancelled. Here 2 3s are 6, more than 6, 6.28, something like that you get in denominator into r. Here 4 into r. So when you compare both of them, this is going to be the greater value, right? So finally the magnetic field will be in the direction of greater magnitude. This is greater, so what we are going to do, we are going to subtract from bigger to smaller. Mu naught I by 4r minus, it is just not like it is minus, it is plus, it is like greater minus smaller. So it's a greater magnetic field, and he will only give the direction of magnetic field, net magnetic field later on, the greater one, divided by, you will write here mu naught I divided by 2 pi r. Right, and here if you take common as mu naught I divided by, if you take common as 4r, actually given in here, mu naught I by 4r in the answer given, so you have to follow with that, and you get 1 minus you get 2 by pi, and since this is the direction final out of the plane. Now this is like, you will be knowing that magnetic field due to a thick wire, there will be 3 different positions will be there for magnetic field. Okay, inside the wire, outside the wire, inside the wire, on the surface, outside. So inside it is actually directly proportional, and outside it goes means it is inversely proportional to distance. So clearly this is the diagram. This diagram will be done in gravitation also. Inside, as the distance increases, magnetic field also increases, becomes maximum on the surface. Again it keep on decreasing. So magnetic field on the y-axis, distance on the x-axis. So magnetic field becomes, starts from here, no magnetic field. Again you are going up to here, it is increases, becomes maximum on the surface, and then again it keep on decreasing. Now here you have to find out the force on a charged particle, and the force formula of charged particle is QVB sin theta. For this condition, theta is equal to 90 degree, because the velocity of the electron is this. Magnetic field will be like, if you take the magnetic field again, if you take this wire, this goes like anti-clockwise into the plane. So theta is 90 degree, and theta actually angle between what? Velocity of charged particle and magnetic field. So Q is the charge is given as electron 1.6 into 10 to the power of minus 19. Velocity is given 10 to the power 5. Okay, and magnetic field due to this wire you get is B is equal to mu naught I divided by 2 pi r. So mu naught is 4 pi into 10 to the power minus 7. Current is given 5 ampere. 2 pi, and distance from here to 20 centimeter, that is 20 divided by 100. So actually it gets cancelled 2 times, and this get cancelled actually 5 times. 5 5 is 25. We have 50 into 10 to the power minus 7. Okay, so here 2 to the 2 pi, and this will get cancelled 2 times, and here 25 5 is 25. 25 into 2, you get 50, right? So here you will write 50. Next, if you multiply 16 and this, you get 80. 16 and 1.6 into 50, if you do, you get 80 into 10 to the power of minus 19 plus 5. So you get here speed was given. Magnetic field is like, we have 50 into 10 to the power of minus 7 is still there. Here we have 50 and this 10 to the power minus 7. So actually you get here total minus 26, and here you get minus 21, and finally we left out with 80. In 80 is there, minus 21 Newton, but in the option given 8, so you write 8 into 10 to the power minus 20 Newton. Here given that two identical long conductor wires AOB and COD are placed right angle to each other. So you need to understand this. Drawing the diagram here in a plane is difficult because it is 3D figure. AOB and COD are placed at right angle to each other. So one wire will be there like AOB, you say AOB, like if you take a wire AOB, right? In this itself, like from the up, you should think something is going like, what you say, we cannot draw it like along the direction of this, it is going up is there, C and O is there. So like perpendicular, how to do here is difficult, I guess. Perpendicular, like AOB is one wire and COD are placed at right angle to each other. Okay, let's see this. Let's imagine this COD perpendicular to each other. This is also, let's see, O is the common center to the wires, right? Point P is lying at a distance D from along direction perpendicular to the plane. Okay, so D you imagine that is at perpendicular above it, right? So actually you have to find out current are there. Current O is the common center for that. The wires carries I1 and I2 current. So this carries I1 and this carries I2, right? So magnetic field due to this at a distance, like you find out magnetic field due to the first wire, that is AOB, magnetic field will get mu naught I1 divided by, you get 2 pi d, distance is given d, and the B2 is equal to, you get mu naught I2 divided by 2 pi d, right? But both are perpendicular, so total magnetic field will be actually root of B1 square plus B2 square. And if you do this square and add, actually if you do square and add it, you will be mu naught by 2 pi d, mu naught by 2 pi d. If you do squaring of this 2, that square will come outside and you will left out with mu naught divided by 2 pi d. Inside written as only I1 square plus I2 square. So mu naught by 2 pi d I1 square plus I2 square to the power of 1 by 2. Now this kind of question actually no need to solve, we can easily find out the answer. The concept is actually when like symmetrical figure we have got a symmetrical figure. It's a square is a symmetrical figure, right? Symmetrical figure. In symmetrical figure, whatever current is going, same current is coming out, right? Current is I, it's made of uniform. The current enters the loop and leaves. That time the magnetic field at the center will be 0. No need to find out. So 0 actually at the center of the loop will be 0. For this the answer will be magnetic field will be 0 at the center of the loop. At the center of this geometric center at the 0 at the center of the loop. Okay, for such situation magnetic field will be 0 at the center of the loop. Now we have to find out magnetic induction at the center O as shown in the figure. So here you could see that there are two configuration is there. Let us say this is our first one, this is our second one, right? So magnetic field at center is equal to magnetic field due to the first part plus magnetic field due to the second part. First part current is going clockwise direction. Clockwise direction you are going, then actually what you will write is mu naught I divided by 2r. It is a part of circle. So mu naught I by 2r, same kind they have given. Mu naught I by 2r. This is but not complete circle. Mu naught I by 2r. That is for complete circle, right? But here some angle is there, and this is subtending an angle of how much? 3 pi by 2, because 3 by 4th. So the angle it is 3 pi by 2 upon 2 pi. Okay, because that is necessary, because it is complete circle mu naught I by 2r. If it is not complete circle, what angle it is subtending out of 2 pi? So it is subtending 3 pi by 2 from here to here, 3 pi by 2 upon 2 pi, and current is going clockwise direction. Current is going clockwise direction means actually you get into the plane. And actually this is the second part, because due to the straight part it will be 0. This is due to the straight part it will be 0, right? Because on the axis of the straight line magnetic field becomes 0. Now magnetic field due to this is first one plus current is actually going here also clockwise direction, so it will be added, both are clockwise, and this is mu naught I. Here radius actually for the first one, radius is given as A, so we will substitute here A. For second one, same current I is there, radius is given as B, so 2B into the angle is here pi by 2, it is subtending angle pi by 2 out of 2 pi, and both are into the plane. So what actually you will get here is, here this pi and this pi will get cancelled, so what you get 3 mu naught I divided by 8A plus here also pi and pi will get cancelled. Here you get mu naught I divided by 8b. So if you take here common, mu naught I divided by 8, if you take common, you are left out with same kind is there, right? Mu naught I by 8, then you get actually 3 by A. 3 by A is there. Here 1 by B, because radius is different, the total magnetic field will be added, so you get mu naught I by 8 into 3 by A plus 1 by B. Now in this figure, let's see that magnetic induction at the center of the arc. Actually this question will be confusing, because you will be starting like finding 3 parts are there. This is first part, this is second part, and this is third part. Now what you will do is that due to this first part is 0, because on the axis of the conductor magnetic field is 0, this also is 0, and this is like you will take semicircle, and you will add all of them, you will get the answer. But the question says that only due to portion AB. What is the magnetic field due to the portion AB? So due to the portion AB, it is actually this point O is lying on the portion AB. So magnetic field due to AB will be equal to 0. There no need to find total magnetic field. Total magnetic field actually you can find out due to first 0, due to third 0, and this is semicircle mu naught I by 4R. Actually many will go with this answer, but here the question itself says that only part AB is interested to know. So that answer will become 0.